So today we are really going to be doing simplifying roots. We're going to be reducing radicals.
Wait, where is the tracking?
It's in Bridgeport. Radicals. Radical, dude. So, we had rational. The word rational meant fraction. Radical means square roots, cube roots. So a radical is any square root, or it could be a cube root, or it could be a fourth root. That's any root. So any root is a radical. So I've been around a long time, back in the 80s, everybody said, radical, dude, radical. So whenever I taught radicals, they're like, whoa, cool, radical, Mr. Davies. Like, yeah, it's pretty radical, isn't it? Anyway, moving on, huh? So what we want to do, and we've done this before, we want to find two numbers that make 24, and one of them needs to be a perfect square. Remember? Remember I did this? So if I take a look at 24, what times what makes 24? 6 and 4. So we got the square root of 6, square root of 4. You guys agree with that? 6 and 4 because what? What's the square root of 4?
2.
Plain old 2. So we write down a 2. There is no square root of 6. It's just an ugly, seriously, ugly number. It's an irrational number. So I get a square root of 6. Square root of 6. Ugh, ugly number. So we just leave it as the square root of 6. Boom. Do you remember doing these before? So it should be and that's the nice thing about reviewing, right, Tammy? Aren't you glad we're going to review it? So just assuming you know this. Okay, example 2. This is a regular 2. That's a regular 2. Leave it alone. But let's break down 18 into what?
9 and 2.
Yep, 9 and 2. Because we know the square root of 9 is 3, right? We wouldn't want to use 3 and 6. That'd be silly. 3 and 6, because that doesn't help us. Square root of 9 is? So we write down 3. Don't forget this 2 is still here, right? Right? Don't forget that 2 is still there. And I get, because I multiply, 6 square roots of 2. Okay? Thumbs up. We've done this before, right? Okay, this is just a review. Example 3. Okay? Am I going too fast? Okay. Keep the 3x where it's at. Just leave the 3x alone. And what do you think about 27? What are we going to break 27 up into? 9 and 3, smart girl. Now, we're going to take half. With exponents, we're going to take half of it, okay? So what's half of 6 is just 3, so we just get an x to the third. Because we know x3 times x3 is x to the 6th, right? You guys agree with that? And that's why we take half of it. We know the square root of 9 is 3. Now let's tidy this mess up. Man, we got a mess here. Yes, we do. So I'd have this 3 times this 3 makes a 9. I'd have this x with these x3s makes x4, right? And then all I got left is this square root of 3, which I'll just bring along for the ride. Because square root of 3 is a really bad number, so we just leave it as square root of 3, which is nicer than 1.73, blah, 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 blah. Natalie, how am I doing?
What?
How am I doing? Am I good? Okay. Thumbs up, everybody. If I get going too fast, will you tell me, please? Okay. All right. Okay, how about 4? Problem with 4 is if I'm going to take half the exponent, we don't want decimals. We don't. So what I'm going to do is make it an even number. So we need to make it even. To make it even, I'm going to rewrite this as the square root of x to the 6th times square root of x, okay? So I take 1 away from it. I want to at least reduce it somewhat. So I need to make an even number out of the exponent, okay? Now I still have this 2, and I'll break the 8 into 4 and 2. Right? Right? I mean, the 8's the 4 and the 2, and this 2 is on the outside, so I just wrote it down. So the 2 is there. 2 is there. The 8 is 4 times 2, okay? The 8 is 4 times 2. And now the 7, I have to take half of it, but I don't want a decimal, so I took 1 away from it, okay? So let's do it now. Okay, this 2 is still there. It's a regular 2. Square root of 4 is plain old 2. Leave this alone. Leave the square root of 2 alone. We'll come back to it. Half, right? Half of this makes a x to the third. And then we can't do anything with the square root of 2. It's an ugly decimal. And we can't do anything with the square root of x, so we just leave it as the square root of 2x. Put them together, right? Put them together, right? Now, let's just tidy it up. I know that 2 times 2 is 4. So I'm going to go 4x cubed square root of 2x. Right? Slide it over. Not yet. Not yet. Am I going too fast? Am I okay? Okay. We have done this before, haven't we? Slide it over. So it's just a nice little review. Okay, number 5, let's just multiply 8 square roots of 18, okay? I multiplied regular numbers with regular numbers, square root numbers with square root numbers, right? The 8's a regular 8, so I'm going to leave it alone. But what do we know about the square root of 18? Let's break that down into what times what makes 18? How about 9 and 2, right? Because the 9 is one of those perfect square root numbers. So we're going to square root of 9, square root of 2, right? We're going to get 8 times 3, because square root of 9 is 3. Square root of 2 is an ugly number. Just leave it as the square root of 2. Get 24 square root of 2, and that's all she wrote, huh? Bailey, how you doing? Good. Okay, number 6 is just like number 5, except it's just a bigger, uglier version of, okay? Number 5 and number 6 are the same kind of problem. It's just a bigger, uglier version. So first, let's multiply and get a 8x. Okay, on the 8x, right? 8x. See my 8x. Square root of 50x to the 8th, okay? Because I've multiplied my 5x cubed and my 10x to the 5th, okay? All right, 8x, we'll leave alone, okay? But 50, what do you know about 50? It's got to be one of those numbers. What do you know about 50? Yeah, 25 and 2 I think is a great choice. And I'm going to take half of that, okay? Take half of that and make that an x to the 4th, okay? So it's the same stuff, just a little bit bigger, a little uglier. Okay, square root of 25 we know is 5, right? X to the 4th, square root of 2. I'm going to put the square root of 2 at the very end. I like the leftover stuff at the very end, right? Does that make sense? I'll put the square root of 2 at the very end. So let's see, I'm going to have a 40, because 8 times 5. X to the 5th, x to the 5th, x1, x4, x to the 5th, square root of 2. Okay, that was pretty bad and ugly, but we can do it. Okay, example 7. Now this one's not so bad. This one's actually pretty easy. Okay, I like to write it as 2 separate square roots. It looks easier if I just do that, right? So okay, let's make it a square root of 20 over a square root of 9, and then I already know that answer is 3, right? But what about the 20? Yep. 4 and 5, square root of 4, square root of 5, right? And we know what the square root of 4 is. What is that? 2. So we're going to have 2 square roots of 5 over 3. Okay, do you ready to turn the page? Right, Natalie. Good luck. Turn the page. Okay. Annalyn, you going with it too?
Yeah.
Okay, now, you cannot have a square root in the denominator, okay? So I don't know if you remember this, but we fixed the problem with the problem. Remember that? We fixed the problem with the problem, okay? So let's check this out. So what I'm going to do right off the bat is rewrite this. It looks easier if I write like this, 4 over the square root of 3, okay? And now, here's the problem. You cannot have a square root in the bottom. The problem is the square root of 3. We fixed the problem with the problem. So here's how I do it. I'm going to multiply both top and bottom by the square root of 3, square root of 3. That's going to actually help me out. So what I did is I made the problem even bigger, but it's going to fix itself. Okay, watch. We know the square root of 3 times square root of 3 is square root of 9, right? 4 times the square root of 3 is just 4 times the square root of 3. You can't do anything about that, right? But now the square root of 9 becomes a regular 3, doesn't it? Right? So then you get 4 square root of 3 over 3. Don't cancel these 3's. Don't. That's not a 3. Come on, Mr. Davies, of course that's 3. No, it's not. That's 1.73, blah, 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 blah. That is not a 3. That is 1.73, blah, blah, blah. So don't cancel them. You're done. Now, did we fix the problem? Is the square root in the bottom anymore? No, it's a silly rule. I didn't make the rule. Somebody else did, but I want to make sure when you go to college that, your college professor is, you know how to do that, okay?
Are you allowed a fractional exponent in the denominator, or just can't have the symbol?
Right, you can't, yeah, you wouldn't, they wouldn't,
Because
they,
you just do algebra.
yeah, that's a great question. It would be the same problem. You still have a radical in the bottom, right?
Like that.
Yeah. Okay, square root of 3 square root of 5, right? Do you agree with that? Fix the problem with the problem, right? Okay, fix the problem with the problem. Square root of 5, square root of 5, right?
Wait a second.
I will.
How'd you do 7 then?
On the front?
Yeah.
Oh, it was a perfect square root, so I was able to boom. Right, straight to it, right? If it is perfect, boom, just do it, right? Okay, so on this one, good question. Square root of 15. And can I skip a step? 25 to make a regular 5. You okay if I skip that step? Now you guys see the 25, which make 5. You okay on that? Right, we know this. 5 times 5 is 25. Square root of 25 is 5, right? Okay. 3. Well, let me rewrite it so it looks better. 5 square root of 3 over the square root of 2. So this is really the same thing. It really is. Fix the problem with the problem. You can't have a square root of 2 on the denominator. So we multiply both top and bottom by square root of 2 over square root of 2. And let's see what happens. We're going to get 5 square roots of 6 over 2. Square root of 2 times 2 squares is 4. Square root of 4 is 2. Am I going too fast? I skipped a step. But square root of 4, right? Square root of 4. Square root of 4 is 2. It's a silly rule. I didn't make it up, but it is a math rule. And it says you can't have, because these two have the exact same value in your calculator. This one just doesn't have a square root in the bottom, okay? Okay, last 3. So this one's different. And I want to show you real quickly why it's different. Don't write this down, okay? So the problem's square root of 3, right? So if I multiply by the square root of 3 over the square root of 3, it will not work. It won't work. Because you know why it won't work? Right here you'll get 4 square roots of 3. You still have a square root of 3 on the bottom, don't you? Okay, so agree with that? So that trick won't work because it's plus or minus. So what we're going to do is we're going to multiply this thing called by the thing called the conjugate. I'm going to write that down. The conjugate. Okay? Now, you don't have to memorize this word, but I will use it. Okay? The conjugate's just the opposite. It's just like the opposite, okay? So I'm going to multiply the conjugate of this, and I'll say it. I'll write it, but the conjugate of this is 4 plus the square root of 3. The conjugate of this is 5 minus the square root of 2. That's all the conjugate is. It's just the opposite sign. So I'm going to multiply top and bottom by 4 plus the square root of 3. 4 plus the square root of 3. Okay? 12 plus 3 square roots of 3. I'll get a 16 plus a 4 square roots of 3, then minus a 4 square roots of 3, then minus a square root of 9. All right, now remember, our goal is to get rid of the square root in the bottom. That's our goal. Get rid of the square roots in the bottom. Okay, but can you see how that's going to happen now? Can you see that's going to happen now? That'll cancel with that, right? You guys agree with that? And square root of 9 is 3. So all the square roots are going to be gone on the bottom, aren't they? So this becomes 3, right? So let's see, I'm going to have 12 plus 3 square roots of 3 over 13. Okay? 4 times 4. 4 times 3 is 4 square roots of 3. Negative 4 square roots of 3. And negative square root of 9. Got it? These two cancel each other out. They always will. That's why you do the conjugate. The middle two terms will always. That's why we do the conjugate. Okay? All right, example 4. You ready? We're going to do the same thing. Okay, what's the conjugate? What's the conjugate? Yeah, so it's just 5 minus the square root of 2. 5 minus the square root of 2. Okay, now I got to do a little foliage on top, but I can handle that. A little foliage, okay? I will get 10 minus 2 square root of 2 plus 5 square root of 3. Uh-oh. Hold on. 5 square root of 3. Sorry, my bad. Minus the square root of 6. Whew, almost made a mistake. I hate making mistakes. Okay? And then at the bottom, we'll have a 25 minus 2 square roots of 2. 5 square roots of 2. There's my second mistake. plus 5 square root of 2 minus the square root of 4, okay? Sorry about messing up a couple of times, but there it is, okay? Alright, what a mess, huh? Well, certainly on the bottom I can do this, boom, and this, right? You guys agree with that? And this becomes the number 2. You guys okay with that? Now on the top, the good and bad news, okay? The good news is nothing can be combined, so we're just going to write it down. Bad news is just kind of ugly looking, right? So then on the top, we really have a 10 minus 2 square root of 2 plus 5 square root of 3 minus square root of 6 all over 23. And that is it. That is it.